Assalamualaikum warahmatullahi wabarakatuh to our lecturer Muhammad Fazil Faisal bin Abdul Rashid and my beloved friends. Today, our group will present the project for industrial engineering with the topic of quality improvement in service sector daily foodie stall. This is the daily foodie stall, and here this is the introduction of this project. This project is about quality improvement in service sector. The premise that we have to purpose in this project is daily foodie stall which located at Balik Pulau in Pulau Pinang. Daily foodie stall is premise which provide food service that has many variation of it. This stall has been in operation for almost 3 years since 2017. We have been hired to help the owner to make improvement for the stall. And this is the problem statement in this project. This stall has faced with a few of problems for almost 1.5 years which affected the stall and the owner. These are some of the problems faced by the stall. The firstly is the small amount of loss at the end of month. Second, this stall do not have specific system to do record. Third, the stall is low in service, and lastly is the amount of employees in kitchen is not economically. The objective of this project is to understand and study and analyze the existing process operation of stall. It is to help in improving efficiency and productivity in the stall. This project also help in increasing the efficiency of the stall through a study on the ergonomics. Next, I will pass the literature review to another group members. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amar Farhan. My metric number is MA16097. Okay, so I'm going to present about the literature review. Okay, so for the literature review, we will discuss about the industrial engineering tool that we will use for this project. So there are three industrial engineering tools that we will use for this project. First is the productivity, second is the time study, and third is the line balancing. Okay, so for the productivity, uh, in productivity they are consists of two two method, which is a single factor productivity and multi-factor productivity. Okay. So for the single factor productivity, it is to measure the productivity, which is the ratio of output and one input factor. So this single factor productivity will measure the output per work input, which describe the work productivity. So this is the product for single factor productivity, uh, equal to output over the input. Okay, so next is the multi-factor productivity. So multi-factor productivity is the total factor productivity. Okay, so this multi-factor productivity will measure the economic performance that will compare the amounts of good and service. So, uh, so the amount of good and service produced. so which is the output with the total of input that will produce a good and services. So this is the uh, multi-factor multi-factor productivity formula. Okay, which is equal to output divided by the sum of labor, material, energy, capital, and miscellaneous. Okay, next, for the second industrial engineering tool, which is time study. So time study is an analysis that do it by a trained person of a particular job in an attempt to determine the most effective technique in terms of time and effort. So this time study industrial engineering tool will examine the time taken to finish a job or task using the right approach. So to define the to analyze the time study, there are 8 steps. There are 8 steps to analyze the time study. So first, we have to define the task. Okay. Second, we have to divide the task into exact element, and then we have to decide how many time to use to measure the task, and then we have to categorize the time in we have to categorize the into time, and we have to record elemental time, and rating of performance. Okay. Okay. Next, for uh, step in time study, we have to calculate the average observed time. Uh, so this is the formula for average observed time. Okay, and the formula is equal to sum of the sum of the time recorded to perform each element divided by the number of observation, and then we have to calculate the normal time. This is the formula for the normal time. Normal time is equal to uh, the average observed time that we get from this previous step, and then times with the performance rating factor. Okay, next we have to uh, calculate the sum of normal time for each element. Okay. Okay, next, for the final step, we have to calculate the standard time. So this is the formula for the standard time. Okay, so for the standard time, this is the formula. It's equal to total normal time, which is the sum of normal time for each element divided by 1 minus with the allowance factor. Okay. Next, the third industrial engineering tools, which is line balancing. Okay, so line balancing is the technique that will equalizing the amount of work at each workstation. So by using this line balancing, we will get the desired output rate with the smallest numbers of workstation, and then we will also obtain the workstation with well balanced workload. Next, okay, so to perform line balancing analysis, we have to draw a precedence diagram. So this is the precedence diagram. Okay, so next, uh, we have to calculate the cycle time. So this is the formula for the cycle time. So the formula is equal to production time available divided by desired unit of output. Okay. Next step, we have to calculate the minimum number of workstation. So this is the formula. Okay, so from the formula, n is the actual number of workstation, and then i here is the number of work element, and then ti here is the completion time for element I, and this cd is the desired cycle time. Okay, next. Okay, lastly, after we calculate the minimum number of workstation, we have to calculate the efficiency to check whether it is efficiency or not. So this is the formula for efficiency. The formula for efficiency is uh, similar with the formula minimum number of workstation, but the difference is the here. So for the minimum number of workstation, uh, here will be the desired cycle time. So for the efficiency is the here will be the actual cycle time. So that's all from me. Thank you.
Next, we move to the case study. This is the location of the deli foodie stall, which is located at Jalan Balik Pulau, Pulau Pinang, Malaysia. And this is the several product that was sold at the stall, which is fish and chip, mushroom soup, nasi goreng kampung, pattaya fried rice. They also sold tom yum soup, curry mee, and western food. And if you can see here, this is the business profile for the deli foodie stall. And this is the main problem that occur at this stall, which is based on overview. Almost 1.5 years, the stall always record a small amount of loss at the end of the business month. And based on our group view, no specific system to record and track raw material that in and comes out. The employee and the whole family eat as much as they can without paying to the business. Next, based on customer view. When based on the customer view, the service is too slow, the kitchen is not systematic, and the dining area, the chairs and table are not safety at all. Based on current issue due to COVID-19, it gives a massive impact to the store owner income. Next, I will pass the another part to group member. Thank you.
Assalamualaikum everyone. My name is Aisyah Mariana binti Musri and A17102. I will continue this presentation with my part, which is methodology. There are several tools that we use in this project to obtain data. The first tool is check sheet. Check sheet is an organized method to record data. The data is recorded by marking on blank form. The check sheet helps us to identify how often the problems occur and customers complain in a period of time. We can know the highest frequency of it and try to avoid it. To use this method, the data observation and collected data must be done only by one person. The next one is SPC. SPC can lead to a reduction of time required to produce the service from end to end. SPC also can reduce cost and improve customer satisfaction. In this project, we use SPC to determine number of customers in a period time. If we know the number of customers that come to the store, we can avoid any waste of product and saving costs for raw material by produce food only by number of customers or by order from customers. The next one is time study. Time study used to analyze the present method of doing a job systematically in order to develop a new and better method. It is also used to measure the time required to do the job for a qualified worker to prepare food. It is important to customers to obtain their desired food on time, which is only possible when the worker is conscious of their time to be taken to prepare food. Time study is important to increase the productivity of the store. In this project, there are 5 job elements that we need to know the time to prepare each food. The next one is moving average method. Moving average method in production planning and control also used in this project. It used to forecast the future units of scale. Time series forecasting is depending on historical data and it is measured based on regular period of time. After analyze the moving average rate, we can construct a sales pattern model. The sales pattern model can be referenced. The last one is break-even analysis. We use break-even analysis to determine the fixed cost and variable cost. Fixed costs remain constant with the number of units produced, while variable costs vary with volume of units produced. The fixed cost in this project is material cost and energy cost, while for variable cost is labor cost. That's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So I am Nur Shazrin Anis, MA17112. So I will continue this presentation with results and discussion. For results and discussion, we calculate single factor productivity. So on our left hand side, we calculate the single factor of productivity all, which is we get 3.2572 unit per labor hour, and then we increase the working hour to 10, and then we got the new one which is 3.5577 unit per labor hour. So we calculate the percentage. So the single productivity increase in 9.23%. It shown that it is more productive when the working hour is increasing. Next, we move to the multi-factor productivity. So for the multi-factor productivity of 8 working hours, we get 0.2867 unit per RM, and then the new one with 10 working hours, we got 0.3271 unit per RM, and then we calculate the percentage change, which is, we can see here, it increased in 14.09%. It shown that it is more productive when the working hour is increasing. Then we move to the Pareto chart. So for the Pareto chart, we know that Pareto chart is produced to analyze the major problem. So from the Pareto chart, we can conclude that deli foodie stall mostly have problem of uncomfortable facility and also slow service. Next, we go to the X chart and R chart. So for X chart, we know that the process is not in control because there is one sample point outside the limits and number of points above and below the center line is not equal. For the R chart, the process is in control, which it fulfill all the control chart requirement. Next, we calculate the time study. So for the time study, we calculate the standard time and we obtain 20.7059 minutes. So it does mean that the standard time for serving a customer is 20.7059 minutes. Next, we move to the line balancing. So for the line balancing, we have 5 tasks here, which is take order, prepare for cooking, deliver food, and then payment. So we calculate the cycle time and we get 9.23 minutes, and then we calculate the minimum number of workstations. From the calculation, we obtain 2 workstations is minimum, but we decided to do 3 workstations as the task should be in 3 workstations. From that, we calculate the efficiency, so we get 63.56%, which is it is better than the efficiency before using this new layout. And then we move to the quantitative method. So for the quantitative method, we calculating the 3-month moving average and also 3-month weighted moving average. So for the 3-month moving average, the highest value is on May, which is 1383.3333, and also for the 3-month weighted moving average, the highest value is on August, which is 1399.1667. This is because for future demand of food in May and August are more than other months, so production rate need to be increased to make sure the aspect demand is achieved. Next, we move to the inventory management. So first of all, we should calculate the optimal order quantity. So we got here 74 units order is optimal. Next, we calculate expected number of units to order, and then we get 4 orders per year. And then we calculate the expected time between orders, which is 78 days between orders. After that, we calculate the annual setup cost. So we get 60.81 ringgit Malaysia. And then we calculate the annual holding cost. So for annual holding cost, it is equal to average inventory level, which is we get 740 ringgit Malaysia. And then we move to the break-even analysis. So for the break-even analysis, we calculate the total cost, which is 4726, and then we calculate the total revenue, which is 9100. So from that both total, we can calculate the profit. So the profit is 4374. So we calculate the break even, and then we get 30 units. So the calculations shows that if the sales are below 30 units, the restaurant will operate at loss. However, if the company sold more than 30 units, it will be profitable.
Finally, for the conclusion, we can conclude that the efficiency and productivity in a stall have been done successfully. Our study using precedence diagram in order to optimize the operational efficiency was conducted successfully. Two solutions are proposed to improve the system and management for the entire food stall. And that's all from us.